Hello, we're here at the University of New South Wales and I'm N J Wildberger. We're having a look now at problem 27 of chapter 1 of the Algebra section. We're dealing with vectors in three-dimensional space and four-dimensional space and asking about distances between them. Alright, so let me remind you first basic definitions that are required for understanding this. So if we have a vector in three-dimensional space, which we can represent by our familiar x, y, and z coordinates. And suppose that we have a vector, say something like this one here, which has components, say x, y, and z. There's the vector v. Then the length of that vector is, first of all, it's denoted by absolute value bars, and it's given explicitly in terms of the square root of the sum of the squares of the entries of the vector. So square root of x squared plus y squared plus z squared. And now if we have 2 points, if A and B are points with coordinate vectors say A and B, then the distance between A and B is, so here's the picture. Now we have 2 points. Let's put them over here. There's A and there's B. We have corresponding coordinate vectors, little a and little b. Then the distance between them is defined in terms of the vector that joins them. The vector AB going from A to B, its length is the distance between A and B. So in terms of a formula, the distance between A and B is the length of A and B, which is the length of the difference between the vector B and the vector A. So this is the basic relation that we use to compute the length of a vector, and so correspondingly the distance between 2 points. All right, so now let's apply this general business to first of all calculate the distance between these 2 points, and then jack it up to 4 dimensions to find the distance between those 2 points in 4-dimensional space. Okay, so for part 1, we're looking at points. A has coordinates 8, minus 4, 2. That's actually the point A. And the point B is minus 6, 1, 0. So then the length of this vector AB is the distance between A and B. And that is the vector B minus the vector A, the length of that vector. So here's the point A, here's the point B. These are the actual coordinate vectors of those. So we need to take the vector B, which is minus 6, 1, 0, subtract the vector A, which is 8, minus 4, 2, and take the length of that resulting difference. All right, so we're talking about the length of the vector minus 14. 1 minus minus 4 is 5. 0 minus 2 is minus 2. And for the formula, we have the square root of then minus 14 squared plus 5 squared plus minus 2 squared, which is, well, 14 squared is 196. 5 squared is 25. Minus 2 squared is 4. So we get all together 196 plus 4 is 225, which happens to be a perfect square. That's 15 squared. So when we take the square root, we get just 15. And so 15 is the distance between these 2 points. These are the 2 points whose coordinate vectors are these ones right here. All right, now for part 3, we're working in 4 dimensions. A little bit harder to visualize, but the algebra is pretty well the same as it is in 3 dimensions. So now the 2 points are 3, 0, 1, 4, called A, and B, which is minus 2, 6, 1, 3. These are 2 points in 4-dimensional space which have these as their coordinate vectors. Well, so similarly as before, if we want the distance between A and B, that's the length of the vector AB, which is going to be the length of the difference between the coordinate vector for B and the coordinate vector for A. So we write that down. The vector B is this one here, minus 2, 6, 1, 3. And the vector A is 3, 0, 1, 4. When we calculate the difference between the vectors, we get the vector minus 2 minus 3 is minus 5. 6 minus 0 is 6. 1 minus 1 is 0. And 3 minus 4 is minus 1. So we're still taking the length of that vector. And now we have to know how to find the length of a vector in 4-dimensional space. Well, it's the same kind of formula as in fact, 2 dimensions and in 3 dimensions. It's the square root of the sum of the squares of the coefficients or entries of the vector. So we have to take minus 5 squared and add 6 squared, add 0 squared, and add minus 1 squared. Let's put all of that under the square root. So for a total of 5 squared is 25, 6 squared is 36, the 0 is not going to do anything, and 1 squared is 1 there. And so the final answer is 25 plus 36, that's 61, plus 1 is 62. Square root of 62 is our answer for the distance between these 2 points in 4-dimensional space.